So now that we've talked about the Java Executor service and we've talked about the thread pool executor class, I want to talk a bit more about the Java Executors utility class. And as you may recall, a utility class is one of these interesting patterns, or maybe idioms is a better term, in Java where you define a class that's final, which means you can't subclass it. It only has static methods. It has no non-static state. And it has a private constructor. So it's really just a namespace for a bunch of methods / functions. There are some methods in the Executors class that are used by other Executor framework classes, such as the thread pool executor. And these are a bunch of sort of helper methods. We'll look at a couple of them real quick. So one of them is default thread factory, which returns an instance of the default thread factory class, which creates a thread that just has default behavior, right? No special properties. It's not a daemon thread. It's a regular thread, and so on and so forth. You can also define instances of thread factory. You can subclass from thread factory and make your own thread factories, not the default ones. You can make custom thread factories. And then you can pass those to the factory methods here. So if you call the methods here, like new fixed thread pool that does not take a thread factory, or new cache thread pool that does not take a thread factory, and so on, it'll use the default thread factory. You can also create your own custom thread factories and then pass them in here to give them custom behaviors. And that can be used to change the priorities, or change the name, or change the type, daemon, non-daemon, all that kind of good stuff. There's also some methods that can be used to adapt runnable objects into callables. So there's a method here called callable, which is basically an adapter that takes a runnable and turns it into a callable. And it does that by creating something called a runnable adapter, passing in the task, the runnable, which is the thing that's going to do the actual computation, and a null indicating there's no return value. So if you take a look here, you can see that a runnable adapter implements callable, and basically what it does is it stashes that runnable away in this task, and it stashes the result in a field, and then when the call method, because it's callable, when the call method is called, it runs the run method and returns the result. So you can adapt runnables to callables, and that's used in a couple of places internally by the pool. The main methods, however, the ones we're going to really focus on, are the factory methods that make different types of executor thread pools. And that's what makes this class really interesting. So it's possible to create a thread pool with just a single thread. It's called a new single thread executor, which is a little bit interesting. The main purpose of that is just to make sure that everything runs in a background thread one at a time. And there actually are situations where that's useful, believe it or not, for certain types of things like command processor implementations. More commonly, however, you use this to create pools of threads. So one factory method is called new fixed thread pool. We've seen that before. You're doing that for your programming assignment, and you'll use other methods for other programming assignments later. As you can see here, this thing is passed a number of threads, that we'll see what that gets used for, and a thread factory. Under the hood, it uses the thread pool executor, which we looked at before. We talked about that earlier. The end threads parameter is passed as the core pool size and the maximum pool size parameters to thread pool executor. So all that's saying is make me a pool of threads with n threads, where n is the core pool size and the max pool size. So never more than n and never less than n. I want n top to bottom. So it's basically a fixed thread pool. You can also see that we pass a 0 here, meaning idle threads don't time out. So even though those n threads are created and even though there's no work to be done, they will stick around waiting for work to show up. They never time out. They never are terminated because they aren't in use, because they're idle. It also creates a linked blocking queue of runnables, so the threads can block on this shared unblocked queue. And the threads can be created by a custom thread factory. So whatever thread factory you pass in there is the one that will be used to create threads. There's also a variant of this that does not have the thread factory parameter, and in that case, it's going to use the default thread factory. And I think that's probably the one that you're using. But anyway. So that's fixed size thread pool. Very simple, but you're always paying for all those threads even if they're not being used. A variant of that is called cached thread pool, and that's used to create variable size thread pools. Also uses the thread pool executor class. New threads are started as needed, but existing threads are reused. So by giving a 0 here, that basically says don't have any threads in the core pool, start with none, and don't let there be more than the maximum size of integers on the machine, which, by the way, is a astronomically huge value, like 2 billion or something like that. So it's unlikely that you will ever need 2 billion threads. If you need 2 billion threads, you probably have other issues with respect to your systems engineering of your app. In this case, however, notice that the timeouts will be 60 seconds. So it'll be up to 60 seconds, and after 60 seconds, if these threads are not in use, they'll be shut down. If work comes in while a thread is idle, but before the 60 seconds has elapsed, then the next piece of work will be given to that idle thread, which will no longer be idle. It'll now be active, doing something. But this means make sure that the thread pool doesn't grow without bounds indefinitely. It'll shut the threads down after a certain amount of time. And notice how this uses synchronous queue. The fixed thread pool used the link blocking queue, which grows, and you queues them up indefinitely because it's unbounded. Synchronous queue has different semantics. It basically does a rendezvous until either an existing thread that's idle can be given the work to, or if they're all in use, a new thread will be created. And as before, you can either create custom threads with your custom thread factory, or you can use the variant that takes no parameters and uses the default thread factory. The third type of thread pool we'll talk about briefly is the work stealing thread pool. We're not going to talk much about that in this class, but just for completeness, there's a way to create work stealing pools. You give it a parallelism count. Under the hood, it creates a new fork join pool, and it passes in the parallelism count. So that's the number of threads you want in the pool. And then it goes ahead and makes a default fork join worker thread factory object. It passes in that information, and that's what's used under the hood to make these things. We won't go through the details of how that works, but that'll be covered in the next class. Okay, so that was the overview of the Java Executors utility class. So when you use those methods, in particular, you'll be using new fixed thread pool and new cached thread pool. Now you have a little better idea how they work under the hood.